In this video, we'll take a look at one manner of creating a control chart, which is a very common kind of visualization, especially with business applications, and especially in cases in which you're looking to reduce variations. But it helps us take a look at variations and try to identify what we call signals, which might be data outliers or some trends that are either moving above or below, or shifts where we see a number of points all above or below within a certain number of standard deviations above or below the mean. There are two methods of creating control charts in Tableau. We're going to demonstrate the first method right now, which is the quick method. And that actually, each method is simply used. It's different in how it creates the upper and lower control limits, or how it identifies those. The quick method uses a global measure of dispersion, which is basically a standard deviation of all the points. The next one we'll talk about in the next video is called the rigorous method, and that uses a local measure of dispersion called sigma x, and that's derived from differences between successive data points. I've attached the data set to your course so you can follow along. Let's learn some Tableau. In this case, the question I'm presented with is to evaluate the defensive performance of one of the greatest defensemen, supposedly, who played in professional hockey in the United States and in Canada, Paul Coffey. Paul Coffey is a Hall of Famer, and one of the key measures of a defender is a statistic known as plus minus, or a metric known as plus minus. And we can find the plus minus in the columns listed here. And it's right here in F9. So we're just going to relabel this plus slash minus. Okay. Plus minus basically takes a measure. It's a simple measure, is that whenever a player is on the ice, it gives a plus for every point that's scored while the player is on the ice, and a minus for every point that's scored against when the player is on the ice. Good defensemen should have a positive plus minus ranking, meaning that they're on the ice giving up fewer goals than when they're on the ice and their team is scoring goals. They're defending against those goals being scored. So if I was to set up a simple control chart to evaluate this, the first thing I would do is remember there's a time series. So I create a simple timeline. So I look at the year. So here, season is the year. So I would put that into the row shelf. I'm sorry, onto the column shelf. And then in this case, since I'm looking at plus minus, I drag this measure and I drag it to rows. What I see here is it's automatically assigned a bar chart. I want a line. Okay. And so now I have my sample timeline here. So I have my timeline. I have my measure inserted. And now I need to go to analytics and start inserting my lines. So I can put an average line in by taking this average line and dragging it through the table. And so we have created our average line. Now we want to create two custom reference lines, and those will be set here. So I go to reference line, and once again I drag it over and I apply it to table, and I want a distribution. 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 And I want a distribution And what I'm looking for is standard deviation. And I want plus or minus 3, comma 3 standard deviation. And I want a line. Not a fill. I want a line. So I'll put that here. And I want to use black, not fill. No fill. I want to use the black line right there. And click OK. So 3 standard deviations above and below. Okay. And so now what we see is we have our average here, our mean, and we have our upper control limit and our lower control limit. So we can even label this if we want. One way we can label it is by annotating. Annotate this point. And here we will call this the upper control limit. Our UCL. Point is right here. And down here, I'll want to do the same thing, and I'll annotate point, and here I'll call it lower control limit. And there's my point right there. So I have my upper control limit, my lower control limit. And so here we now have our view. So each season we look at, and one of the things I also like to do is I always like to label the points if I can. So what we see is we now have to look for our signals, so we're always checking our signs. To see where are these key outliers or variations. So if we do the quick look, we don't see any outliers, right? We don't have any points above the upper control limit or below the lower control limit. Okay, so that's good. We've got that under control. Do we have 7 or more points in a row, all ascending or descending? Well, we have 1, 2, 3, 4, 5 in a row that are descending, so not ascending. Okay. We have 1, 2, 3, 4, 5 in a row here that are ascending. Okay. Do we have 14 points alternating up and down? No. Are 2 out of 3 consecutive points more than 2 standard deviations above the mean? So for that, we might add another standard deviation line, and we can keep adding reference lines. So here, I would add just another reference line here to the table, and it's a distribution, and it's a standard deviation, and here it's -2, comma 2. Okay. And I want lines here. Let's put dashed lines. No fill. And that's okay. And then I can even add another reference line because I know one of them is going to ask for 1 standard deviation. So I can also go to a distribution, And once again, I go back to standard deviation, 1 and 1. Okay. And I can go to this kind of dashed line. No fill. Or you could make a fill if you thought that would fit. And so here we have 1 standard deviation, 2 standard deviations, 3 standard deviations, okay? So are 2 out of 3 consecutive points more than 2 standard deviations above the mean or below the mean, right? So 2 out of 3 consecutive points more than 2 standard deviations above the mean. Well, are there more than 2? Nope. Nope. Okay. Are there 4 out of 5 consecutive points 1 standard deviation from the mean? Let's see. 1, 2, 3. Nope. Nope. Oh, wait. 1, 2, 3, 4, 5 right here. Okay. But is this a sign of something that's bad? Well, no. Actually, in hockey, this is a good thing. It means that this player has been on the ice with a squad that's scored a lot of goals, and they haven't let many in. So as someone responsible for defense, this player is responsible for a good job. Now, if we were looking to limit variations and try to keep things within this range, then we would be concerned. So the application may differ, but in this case, we're not so bad. Okay. Do we have another 4 or 5 consecutive points, 1 standard deviation above or below the mean? Yes. 1, 2, 3, 4, 5. The last 5 seasons of this player's play, Paul Coffey's play, were below. So what we get is a way of examining variations, and we get a little more sophisticated with it. So we're moving simply beyond the averages, and we're finding a way where we can plot and also figure in, how these data points that lie outside, 1 standard deviation, 2 standard deviations, or up to 3 or more standard deviations away, what they mean. And so this is a common data task that you may get, and Tableau makes this very easy. And so this can become something quite handy. Now, let's say I had a list of players and I wanted to do this. I could actually filter my players. So if I downloaded player statistics over all of these years, I could dump the players into filters and filter the players and go player by player. And so that's something that Tableau makes very easy. And so that's an application you could look at. Now, one of the other things that we might apply this to is, for example, let's say you have customer service KPIs in your organization, and you have a CRM that keeps track of some of these. You pull raw data and you're looking to do an analysis of this, and it gets sent to you. And this is a common way that, visualization that you can make for a manager in that unit or an efficiency expert in that unit that would make sense to that person and help them dial into a specific employee. So you could even make this into a usable filtered dashboard and share that, and then have it connected to your data source so it's always updating. So that would be another example of using a control chart, and how easy it is to make a control chart just using the quick method. In our next video, we'll take a look at making a control chart using the rigorous method.